We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Environmental Conservation and Hazard Management, Unit 3, Wind Power. Introduction and Potential of Wind Energy in India. Air in motion is called wind. When winds are blowing, they carry enormous amount of kinetic energy which can be converted into useful forms of energy. Winds are produced due to convective circulation of air induced by the temperature differences in the atmosphere. On a global basis, the primary surface winds are produced from poles to the equator. When air at the equator is heated up, it becomes lighter in density and moves up. The cold air from the poles rushes in the direction of the equator to fill up the space left behind by the heated air, which we call as winds. The local winds are produced due to differential heat transfer mechanism of water bodies and land mass. Heat absorption rate of land mass and water mass in the sea is different due to difference in the specific heat of land and water. Due to the heat of the sun rays, the land is more rapidly heated up, while the sea water is slowly heated. In the night time, the land is quickly cooled, while the sea water remains hot for a longer period of time. Due to these differences in heat transfer rate, the temperature differences are always remaining at daytime and night time. During the daytime, the sea water is at a lower temperature than the temperature on the land. The air in proximity with land is heated and goes up as it becomes lighter. Hence, the surface winds produced from the sea water from to land. During the night time, the situation is reversed. The sea water is at a higher temperature than the temperature on the land, and hence the surface winds produced are from the land towards the sea water. These are known as local winds. The potential of wind power generation in India. The potential of wind power in India is inexhaustible. It can be estimated that at the current level, which would be around 8 to 10 years back, the amount of energy generation potential in India would be a staggering 45,000 megawatts or more, while during the present situation, that is during the year 2012, it was around 17,644 megawatts as reported in the same year. Even though India is a new entrant in the wind power industry, it has compared to the developed nations the combination of the domestic policy support and the strong manufacturing base have given the growth of wind power generation its necessary boost. A list of some states is shown below. Tamil Nadu, which has a capacity of 6,970 megawatts. Gujarat has a capacity of 2,884 megawatts. Maharashtra 2,310, and so on. The Government of India has launched various schemes: cost reduction of installation, modern manufacturing, and easy availability of finance. Samana in Gujarat's Rajkot district is set to become a major hub of wind power energy in the country as an energy source. It is an ideal location for installation of about 450 turbines, which could generate a total of around 360 megawatts of energy. Tata Power, ONGC Limited are some of those which have committed to develop the wind power generation not only in Gujarat but in India as well. Wind maps. The Government of India runs more than 500 meteorological laboratories all over India. These observe and collect important weather data, which includes the wind velocity and wind direction. The anemographic stations in these laboratories record the data related to wind speeds and wind direction and map them on time basis. Such maps are called as wind maps. Wind maps help us to find the average wind speeds and wind direction to estimate the wind power which can be generated at the place. They also help us to find the average wind velocity, direction for estimation of harvesting the wind power in that particular region, and suitable areas are then selected and they are recommended for the installation of the wind turbines. Coming down towards mapping of the data. Different observations are used and the characteristic maps are drawn on the basis of these observations. Following observations are required for mapping of a wind map. The hourly mean and peak velocity of wind in kilometers per hour, daily mean peak velocity of wind in kilometers per hour, monthly mean and peak velocity of wind in kilometers per hour, and yearly mean and peak velocity of wind in kilometers per hour. The hourly mean and peak velocity of wind in kilometers per hour can be defined as the average velocity of wind in kilometers per hour during any hour of the day. It helps in finding out the maximum velocity during which hours, and also in designing of components like tower height, types of blades, etc. Daily mean velocity of wind in kilometers per hour. It is defined as the average velocity of wind in kilometers per hour during any day of the month. It is calculated on the basis of hourly observations and velocity. The next comes in the monthly mean velocity of wind in kilometers per hour. It specifies velocity of wind during any month of the year and calculated on the basis of daily average velocity. Helps in calculating amount of wind power produced in a particular month. The last is the yearly mean velocity of wind in kilometers per hour. The yearly mean wind velocity can be defined as an average velocity of wind in kilometers per hour during any year. It is calculated on the basis of information of monthly average velocity of winds. This information helps us to know the possibilities of generating wind power at any particular place and select the ideal site for windmill. Nowadays, modern technology has helped us by plotting computerized wind maps and providing accurate wind speeds and direction. Here is a diagrammatic representation of the wind map of India. It shows the distribution of wind at different places. These wind types can help us by giving us a lot of other data. Wind maps showing annual distribution, daily average, wind speed. The wind maps showing annual distribution, monthly average, surface wind speed. Daily, monthly and yearly distribution of upper wind speed. Wind maps showing annual distribution of peak value of wind speed. 50 years average state-wise wind maps, and lastly the peak gust and velocity maps. Coming to the next part, the wind graph and data. The hourly wind speed is highly variable and unpredictable. It has the maximum value called gust value and also average value. Both these parameters are very useful and are recorded by Indian Meteorological Department at different places in our country. Over and above wind maps, Meteorological Department prepares the various data base of winds in the forms of wind tables, graphs and histograms. They provide all information regarding pattern of blowing the winds at a particular place. These database is stored at the National Data Center IMD Pune and are useful for designing tall structures like multi-story buildings and towers, airports and harbors. They are also used in aviation, shipping and fishing industries as well. The uses of wind maps and wind data. It helps us to know the potential of wind energy at selected place and how much wind power can be generated at the place. To estimate the capacity of wind turbine and wind generator. It also helps in selecting types and design of wind power equipments and machines that need to be installed at the selected place. It helps us in inferring the climatological status at any selected place. Lastly, it also helps us to identify where there is a good potential to generate wind energy. The instruments that are used to measure direction and velocity of wind. The first instrument that is used for measuring the velocity of wind is Anemometer. An anemometer is a device that is used for measuring wind speed as well as direction. It is also commonly called a weather station instrument. It is a term derived from the Greek word anemos, which means wind, and is used to describe any wind speed instrument used in meteorology. The airflow past the cups in any horizontal direction, which will turn the shaft at a rate that was roughly proportional to the wind speed. Therefore, counting the turns of the shaft over a set time interval produces a value proportional to the average of wind speed for a wide range of speeds. It is also called a rotational anemometer or a rotating cup anemometer. Next is wind vane. A weather vane or a wind vane, or even referred as a weathercock, is an instrument used for showing the direction of the wind. It is typically used as an architectural ornament to the highest point of a building. It helps us in determining the wind direction, as a wind vane spins and points in the direction from which the wind is coming, and generally would have two parts or ends. One that is usually shaped like an arrow and turns into the wind, and the one that is wider so that it catches the breeze. Therefore, a west wind is blowing from the west. These are the diagrammatic representations of a rotating cup, anemometer and a wind vane. Now, let us all view a video related to the instruments used for measuring the wind velocity and wind direction.
When air moves, it's what we call wind. Although we cannot see wind, we can feel it and see it blow leaves, flags, and washing that has been hung out to dry. Winds are changeable, but some are more predictable than others. Weather forecasters try to work out where wind will blow and what weather the wind will bring. They are most interested in wind direction and wind speed. A wind vane is used to show wind direction. It is placed on top of a building or a large pole called a mast, and the wind causes it to move and point in the direction that the wind is coming from. For describing wind direction, we use compass points: north, east, south, and west. Wind direction is the direction wind is blowing from, not where it is blowing to. Therefore, if wind comes from the east, we call it an easterly wind. At an airport, you may see wind socks. They are also used to show wind direction, but they show where the wind is moving to. It is also useful to know wind speed. To measure this, we use an instrument called an anemometer, which looks like this. The faster the wind, the more quickly the cups on the anemometer spin around. It is important to know the speed of a wind. The faster it is, the more damage it can do. We have different words to describe how fast a wind is blowing. A gust is a sudden rush of wind which can catch you by surprise. A gale is a very powerful wind. It can be hard to stand up in a gale, and it's best to stay indoors.